in a few minutes.
Okay, so are we all right? Okay, okay. Okay, thank you very much. So hello everybody. Welcome you all to our application spotlight on audiovisual analytics, potential applications of combined sonifications and visualizations. I'm Wolfgang Eigner. I'm one of the co-organizers of this application spotlight here together with Niklas Elmquist, Kajetan Enge, Robert Höldrich, Michael Iber, Alexander Rindt, Niklas Rönnberg, and Bruce Walker. Part of us are here, so Niklas and Kajetan are here in the room. Alexander and Bruce are here with us over Zoom and will be joining in a little bit later on. I just wanted to give you a little bit of information about the motivation of that whole thing. As I'm a person from the visualization community, a visualization researcher, Kajetan, on the other hand, is from the audio community, and that already says it pretty much. So the idea is to bring together people from both of these domains and to work together. And I just looked up the definitions for those fields just before. So, and some of the most often read ones are: sonification is the use of non-speech audio to convey information, and visualization deals with the graphic representation of data and information. So you probably see there is some commonality here in our goals, what we actually want to do. The means are a little bit different. And this also came to this observation that although we have very similar goals to what we're going to do, our communities are not very close to each other. So there's not a lot of work out there research-wise that combines the two modalities, and there's not a lot of application work out there. And that's the reason also why we have this initiative. We had a couple of events already, and Kajetan will give you a little bit of an overview of what we are aiming for.
Thank you, Wolfgang. I will give you a brief context of what we are doing at University of Applied Science in St. Pölten in Austria. We have a research project going on, and the name of the project is Sonivis, and what we are essentially doing is we're trying to combine visualization and sonification in the context of exploratory data analysis with the vision, the long-term vision that a human analyst that is able to use both their visual and their auditory sense may find more patterns, different structures, engages more, all of these questions one can ask themselves. In the context of Sonivis, we also do AVAC, Audio Visual Analytics Community, and what we do today is one of our events. We also do meetups. Those are virtual and very informal. They happen every second month, and you're very welcome to join them, and you will be able to sign up later if you're interested. We also do workshops, or in this case, application spotlights. We've been to Audio Mostly, to Viz last year, to AVI this year, and today again to Viz. Our program for today is Oystein Moseng and Bruce Walker will talk about a collaboration of theirs, HighChart Sonification Studio. Sara Lenzi and Paolo Ticorelli will talk about their project, the Data Sonification Archive, and Victor Adriel de Jesus Oliveira will talk about how sonification is and can be used in health promotion and rehab. And before, one more thing here, we have a website that's the left side QR code, and a Discord server, the right side QR code. If you want to join those, I will show you these QR codes later again. And before we start with the talks, I would like to give the mic briefly to Niklas here, who's also invited to tell you on his side.
Yeah, welcome everyone. I'm Niklas Almquist. I have been part of the effort for a while now, since the beginning, and my interest is in the accessibility and sonification uses for people primarily with blindness or visual impairment. All right, think that's it for me.
Okay. We will start with the HighCharts Sonification Studio presentation, and I want to briefly introduce two of our speakers here. Allow me to read this off mostly. Øystein Moseng is the head of accessibility at HiSoft, the company behind the HighCharts that many of you may know. He has worked with companies across different sectors, including laboratory technology, medical equipment, and consumer products. He has led the accessibility research and development efforts of HighCharts products, going beyond compliance to focus on advancing the field of data visualization accessibility. Bruce Walker is the director of the Georgia Tech Sonification Lab. That is Alex, not Bruce. The Sonification Lab focuses on the development and evaluation of auditory and multimodal interfaces and the cognitive, psychophysical, and practical aspects of auditory displays, especially focusing on sonification. Bruce is passionate about making schools and educational materials more accessible for all learners, which led to decades of work on assistive technology. Øystein and Bruce, thank you very much for joining us. Let's listen to your presentation.
Excellent. Thank you for that introduction. Let me see if I can share my screen. Okay. Yes, so excited to be here, even if it is digital. I am joined by Dr. Bruce Walker, and he will take over in a second. And we are here to introduce you to our HighCharts Sonification Studio. And if you're not familiar with HighCharts, we've been around for a while. We're a company that primarily caters to developers, programmers, helping them create modern data visualizations. And I don't know how well these animations are coming across here as we're streaming, but hopefully it can give you a bit of an idea of the sort of visualizations that people might create using HighCharts. My focus area with HighCharts in the later years, at least, has been on accessibility. And obviously, there are a lot of challenges with data visualization accessibility. And one of the big challenges is large data sets. So if we have charts with hundreds or with thousands of data points, then if we have blind users or users who for various reasons might not be able to see the charts, maybe they have to have their attention elsewhere. It's a real struggle to communicate that data efficiently. So a few years back, we started working on sonification with HighCharts and incorporating that into our programming tools. And a little while later, we reached out to Bruce and his sonification research lab at Georgia Tech, and we discovered that there is actually a need for a tool in the market where anyone can experiment more with sonification without having to be a developer. In order to experiment with sonification and in order to perhaps prototype, and we'll show you some of the use cases. So that's really what this is and what we're hoping to show you. So it's a free online tool for experimenting with sonification and with charts. And for us at HighCharts, this has been a great project to learn more about sonification as a field, the science behind it, and what's required for an effective sonification, which is something that's going to help us in the development of HighCharts. But this product is completely free and just an online editor that anyone can go in and use. So with that, I think I'll hand it over to you, Bruce, for a quick demonstration.
Thank you very much. I'm going to share my screen here and proceed with a very quick overview of the HighCharts Sonification Studio. This pulls all of the power of the modern graphing and charting from HighCharts and incorporates a lot of the know-how and experience from the Sonification Lab and other products and software that we've built in the past. For example, some of you may have heard of the Sonification sandbox. So the HighCharts Sonification Studio is the next generation of that. So if you go to sonification.highcharts.com, you get to a landing page, you click on go to the app, and you're going to get to an interface that looks a lot like this. Let me give you a bit of a tour. You're seeing a chart view, and you see the chart tab is activated. There's the ability to play the data. You can import and there's menus for projects, a new project, old projects can be opened. You can save a project. You can import CSV data. We'll talk more about that. You can export to a lot of formats. You'll see a visual chart and a lot of settings. You'll also see a data tab. The data tab can comfortably import CSV data. You'll see that it gets the column headers and all of the data values. The chart here can also bring in data directly from a Google Sheet. We won't demonstrate that today, but it works great if you have your data stored in that way. You can also take advantage of a lot of tools to fill columns using formulas. For example, I could fill column C with 2 times the data from column B or what have you. All right, going back to the chart, we see on the right-hand side settings tabs for the visual data and for the audio settings. Back to the visual side, we have global settings that adjust the entire visual chart. And then we have settings for the visual aspects of each data series. Similar, the audio tab has global settings that apply to the sound coming from the entire auditory chart, if you will, and then settings for the audio output for each of the data series. One of the things that's probably coming across is how many options there are. It may seem overwhelming for me to click through like this, and that's actually a feature in that there are many things and many capabilities already built into this system. I'm going to do a very quick demo that will gloss over many of these settings, but I want to make the point that this is a very powerful tool that can be used out of the box, if you will, by beginners on the web. The interface is meant to be accessible to users of screen readers and so on. So let's do an example here. I'm going to import some data. I'm going to use CSV data. I'm going to use some data that I have stored on my hard drive. And if I go to the data tab, you will see the dates in the first column, and then US total cases, Spain, USA new cases in Spain, 4 columns of data. When I look at the chart, I'll go back to the chart, and oh, by the way, you'll see that when this table imported the CSV file, it did a good job of recognizing the first column as dates and importing those appropriately. All right, so I go back to my chart, and we can look at what we've got here. I'll start visually and go to my global settings. The basic kinds of things you can set are your title. If you wanted to, you could do that here. You can change the type of chart, scatter plots, or but I like the smooth area for this purpose here. All right, we can go the x-axis. We need an x-axis title. I'm going to call this date. Date. Note that the import function recognized the x-axis as a date and formatted the data and the axis properly, but we could have category or logarithmic or linear axis types. For almost everything, we can determine whether we want that feature visible or invisible. We can set minimum, maximum, the various kinds of things you might want. What about our y-axis? Well, again, it defaults to a simple title of values, but let's just say total COVID cases. Oh, boy, my typing today. All right. Again, we can set it as various kinds of axis types, minimum, maximum, trimming, and so on. A couple other things we want to show here under advanced. Let's put a legend on our chart, and you'll see that it appears on the bottom. You'll also see that there are 4 items in the legend showing all of the columns in the data. And you know what? I'm going to show the data series to help us remember what we're looking at here. All right. Now let me go to the data series tab. We have four series in here, but today we're going to focus just on 2 of them. So let's look at the USA total cases. I'm going to give that a better name for now, just short form. It's visible. It's the default type, and let me give it a color, nice blue color. Great. Oh, blue color, pick a blue color. Good. Great. Now let me go to the Spain total cases, and I'm going to call that Spain. And I'm going to change the color of that, give that a nice red color. All of these things are super simple to do. And one more thing I'm going to do is make those extra columns, the columns for new cases, we're going to take those off. You may or may not be able to see it, but at the very bottom of the graph here, there were little squiggles that represented those new cases. They're going to go away. You'll also see that in the legend at the bottom of the chart, those items are grayed out. All right. Well, so you can see how we have a very straightforward way of creating and distributing and tweaking a visual graph. Lots of power there. But what about the audio? On the audio side, well, as soon as you create the graph, it will set very smart defaults so that you can play it immediately. Hopefully this is, tell me if this is too loud. Okay, and so that's just out of the box what we get. It's a little bit fast, so I could change the playback speed a little bit. Let me just turn that down. You'll see that the system indicates how long the playback will be. There's other features in here that we can talk about perhaps later. Other default audio settings you'll see, you can change the minimum note range in terms of MIDI notes. It'll default sort of in the middle of the MIDI range. By default, panning is enabled so that if you're listening through stereo headphones, you'll hear the sounds start on the left and then play over to the right. You can turn that on or off, and you can set that for each and every data series separately. We'll leave it on for now. And this last little section here is the opportunity to provide additional context. So for example, a click track that you may want to put in there just for fun. So I'm going to add a new one. Play every month, right? It knows that our x-axis is a date, so it's going to pull, it's smart about that. And we're going to do that always, every month. You can change the instrument that is used, the volume. I'm going to turn it down to maybe 56. You can change all aspects of that, but this is just going to give us a click track. All right, so I'll play this. Now the click track is quite soft, so I'll maybe turn it up a little bit, but you can see how that's very easily managed. All right. Maybe I want to make the case that the USA had a lot of COVID, and we can make this very compelling. We can change by going to the data series settings for the audio. I'm addressing the USA settings here. I can change the instrument. We have, I'm not sure if you see these drop down okay, so you can see various instruments, flute and trumpet and so on. Those are the ones that are built in. And we also see sine and sawtooth and a few other percussive sounds. That's fine. What I'm going to do here is you can see the pitch can be default or it can be mapped. The panning, as we've discussed, left to right. The volume, let's set the volume to be mapped. It's going to start in a middle volume and it's going to be mapped to Y. So basically, as the Y goes up, it's going to get louder. And the intention here, as you know, COVID cases rise, the sound gets more, higher volume, louder, in addition to rising in pitch. But let's make that even more kind of aggressive and say, what about some tremolo? So we get the tremolo, and we're going to map that as well, so that as the Y value rises, it gets even more tremolo. Okay, so let's listen to this and see if the intent comes across. Right, and so very quickly you can adjust all the various parameters. There's a lot of data here, so we have a sort of smooth curve, but if we had a smaller data set, then we can play the individual notes. That all works out great. We can also kind of sample the data set and play less detail. That's a setting that we have as well. All right. We could go on and on about this, but let me just briefly talk about the export options. You can export this
Bruce,
as a video, in which case it'll
I'm
play.
sorry, Bruce. May I interrupt you? If you could actually really come to an end in 2 or 3 sentences, I would be very, very thankful.
Yep, absolutely.
Out of time. Thank you.
Yep. So we have lots of opportunities to export in lots of different formats. Most notably, a file format called the High Chart Sonification Studio project file, which you can save and then reopen to continue your work or share the file with someone else. All right, thank you, and I will stop sharing.
Let's give a hand to Øystein and Bruce. Thank you very, very much. In general, please ask your questions in Slido. If you have a question, I did not see a question so far. Let me just switch over there to make sure. If you have a question here in the room, please just tell me. I will bring you the microphone. If there are no questions, there is a question by Wolfgang.
Thank you. So the question is more tied to the business side of things here, maybe to Øystein there from a product point, as this is also an application spotlight. So do you have any data on the uptake and usage of the features that combine visualization and sonification in your product?
We have some use cases from large corporations in particular that have been interested in using sonification in their use of high charts as a programming tool, mainly for accessibility reasons. And I'm very careful with naming names because of non-disclosure agreements and so on. But that has been an interest, and we're expecting that to increase as we're also increasing the visibility of these features also through this collaboration. As for the uptake on this particular tool, it's still very new, and we're implementing analytics probably tomorrow. So I will know more after that, and hopefully all of you will try it out and let us know what you think.
Thank you.
Thank you. Actually, I lost my connection to the Wi-Fi, so I don't know if there are questions in Slido. Let me just refresh this. In the meantime, I would have one more question, maybe for Øystein also. Oh, there are. Wait. Mistletoe, there are. 1 second. Recent, popular. Let's go for the most popular one. Is there an automatic mapping between the visual and audio setting, for example, changing the chart from line to scatter plot? Maybe, Øystein, if you would want to talk about this.
Yes, I mean, the only automatic mapping would be things like whether a series is visible or not, also impacts if it's played back. As far as changing the settings of the audio just because you change the visual appearance is not something that we're played with yet. It could be interesting, could be confusing, so we'd have to look into that.
But whatever you set the visuals to when you click on play, it will play. And it will sound pretty decent. So there is sort of a default, and the defaults are still a work in progress.
Thank you. There are actually many more questions in Slido. We will keep them in our heads, basically, for the Q&A panel in the end. And we'll now continue with the next presentation. And I will introduce Sara Lenzi and Paolo Cicurelli real quick. Sara Lenzi is a postdoc researcher at the Critical Alarms Lab at TU Delft. After a decade in the sound design industry, she pursued a PhD in design at Politecnico di Milano. Her research focuses on the use of sound to represent and describe complex phenomena, and she's particularly active in the current debate on the designerly approach to data sonification and the formalization of shared tools and methods for sound design. Paolo Cicurelli is a professor of design at Northeastern University, where he founded and directs the Center of Design. His research focuses on design-driven data transformations across different languages and modalities to address non-expert stakeholders, especially. Paolo is currently co-editor of Big Data and Society and chaired the Communication Design program at Politecnico di Milano, where he also founded and directed the Density Design Research Lab from 2010 to 2019. They will tell us about their project, the Data Sonification Archive. Let's listen to their presentation.
Okay, so I go first. I'm Paolo Cicurelli. Actually, I will introduce right away the Data Sonification Archive. That is a kind of a byproduct of the research journey that started when Sara joined Politecnico di Milano first, and then Northeastern University, first for the PhD and then as a research scientist at the Center for Design at Northeastern. A journey that we started together, crossing the research on information design that we were doing at Density Design and the work around sonification that Sara was doing at that time. So you have here another couple of design and sound, data visualization, and sonification. As designers, when we do research, we tend to do research actually by designing things. So we call it research through design. And so together with the typical literature review that you may do in research, we always perform a kind of a systematic observation of the phenomenology and the practice within the domain that we are researching. So we started to search and collect cases, evidences of people, projects, initiatives that were trying to transform data into sound or making sense of data in different contexts, any context, any purpose at that time. We found some, but it wasn't really easy to do that. So we saw that kind of a potential in that research process that we started, in this collection of cases that we started. So I'm kind of personally obsessed with the idea of creating as much value as possible at each and every step of the research process. And that's what I always say to my students, nothing should get wasted or underutilized. So, and as designers, I think we have a kind of an advantage because with our ability to shape artifacts, we can make the knowledge we produce through research visible, shareable, and create some sort of engagement and collaboration around it. And so that you can look at the data sonification archive as this kind of artifact. It's a kind of a catalyst, it's an object, a prompt for other people to react. And so that's what happened. It in fact it attracted other scholars and multiplied for us the opportunities to discuss and reflect on that. So we started, as you may guess, as usual with archives, from structuring it and creating the metadata for describing the cases. And by the way, all the metadata that we created on the 400 cases that we have in the archive are published under Creative Commons license, so everybody can use them for analysis. And and that's always a pretty interesting phase. So by creating those metadata and the categories, you really spend a lot of time reflecting. So each category, each metadata is a very dense item where hours, if not weeks, of reflections on the nature of each case, on the intentions behind it, collapse. So some of these categories and metadata have been derived from data visualization. It was part of my previous research. So that classical polarity, for example, between analytical and narrative. So you may see something that is familiar in the categorization or in data visualization, but then others that were specific of the sonification field. And speaking about values, some of these categories have been further transformed into other artifacts. Like, for example, a data sonification canvas. That is something that we created as to help non-experts, especially, to jumpstart sonification initiatives. And you can recognize some of these boxes, some of the categories and the metadata that we used to create the catalog. And this is also something that has been published under Creative Commons license. But one column especially attracted our attention and became pretty interesting is the one that is called Media Mix. You can see it here, where we're trying to acknowledge the fact that sonification rarely comes alone, meaning that more and more we were seeing cases where sonification were coupled with another means of data transformation. So you could see sometimes it was not really data visualization, but it could be a picture, a video, but it was something more than just the sonification. So we created that column, but on a certain point we wanted to dig deeper into that and to expand a little bit the column. And with an occasion, with the occasion, actually, the encounters that were the meetings that were already exploring the synergies between the visual and the audio, that we got that occasion to create a new set of metadata that was meant to kind of open up, elaborate more on the column, media mix column, as we called it before. So we see here the two different sensory modalities and other, the function, again, analytical and narrative topics, if it's interactive or not, but Sarah will talk more about that. Actually, we found 88 cases within the archive, is kind of 20% of all the cases where sonification and visualization coexist. And we used some of the metadata in the categories to create a kind of a subset of that. And now Sarah will drive you through some of those cases to explore different ways for these two stanzas to coexist in a representation of data.
Thank you, Paolo. And if you unshare, I will share my screen. Yeah. So I take it from here to comment some of the insights that we are getting for what we now call Cayetan, the AVAC collection. As you see, very quickly, as you see, the use cases that we identified, the cases that we identified are quite balanced between those cases that have as main purpose to tell a story, so the narrative function of a project, and those cases that instead would serve data analysis. In terms of sensory modality, it's interesting to see that even if the vast majority of the cases start from sonification. After all, this is a sonification archive, and added visualization at a later stage. That the very interesting bulk of cases that we labeled both, in which sonification and visualization were conceived at the same time. And most of the both cases are taken by a narrative function. We said oral is the sensory modality that comes first in the majority of the cases. Then we have those that equally use both. And then we have a tinier part of our selected cases in which the data visualization came first and then was also helped or supported by a sonification. And interestingly, the majority of these cases are also interactive, are non-interactive, whereas the majority of the interactive cases are once again occupied by projects that use both modalities. So it really seems that there is something in the relationship between visualization and sonification that adds value to the experience. Last Sankey diagram before sharing some examples. Again, we can see the function, narrative and analytical, how they relate to interactivity. The majority of the cases are not interactive, but we still thought it was interesting to raise this point and to see how the function relates to that. Once again, when we tell a story, perhaps we try to engage the public through interacting with a system more than when we need our users to perform analysis. And in relation with interactivity, yes or no, and which sensory modality is predominant, we can see that, again, both cases relate to interactivity. Both cases, I mean, both modalities happen together with equal importance, more when we are talking about interactive cases. We selected 3 examples, mainly due to time constraints, that cover a little bit the spectrum of these 88 AVAC database cases. The first one is Datascapes. It's a recent project by Stephen Roddy. It was released this year in a prototypal way. And in the words of the authors, Datascape is a multimodal web analytics framework that, as a prototype, is using COVID cases, similar to what we saw as with high charts. It looks that really COVID and the data, the huge amount of data related to COVID really impacted what we do. So Datascapes wants to be a front-end alternative to purely visual dashboards. So I would say the endeavor is quite similar to high charts. Even if it's a personal project, Stephen Roddy is an advocate of what he calls embodied sonification. So this framework is supposed to leverage embodied metaphors to connect visualization and sonification. The goal here is clearly analytic. This is to run data analysis, and the question that we would like to leave to the audience, and perhaps we can discuss it later with Oystein and Bruce. Of course, they will have some answers in that respect. Can we really perform analysis with sound as we do with visualization? Are they really equal on the same plane? What are the challenges? And of course, what are the opportunities? Let me play some examples from the Datascape framework as it is at the moment. As you can see, you can visualize with traditional visualizations some of the COVID data sets. And then you have a button and you can also sonify the data. Things get more challenging when we start sonifying trend lines. Play it for you. So while preparing this presentation, Paolo and I had long talks on what works, what doesn't work, how the intention of the author of this project then is fulfilled in practice. Another project, very different, Conductor by Alexander Chen, was an engineer who works at Google, is quite dated now, 2011, but back then when it was released, it got some traction and some echo on the media. In fact, I'm quoting here from the Huffington Post that says it turns the iconic New York City metro map by the information designer Vignelli into a musical instrument. So this creates an experience, again, an experience in which visualization and sonification were conceived and designed at the same time to create what the author calls an interactive music instrument, where the metro, New York tube system, underground system are visualized in real time. And when they cross, hopefully they cross fast enough. When they cross, the interactive, this is one of our interactive cases, the interaction between the lines transforms the visualization into a musical instrument. So this is a case in which the intention of the author is clearly to tell a story and to change our experience, our perception of the metro system map in this case. And then a third case that is kind of perhaps a midway between the two is part of a collection by the meteorologist Benjamin Renat, and is part of a European-funded project about hydroclimatic data, and in particular, the project studies extreme climate events related to precipitations and floods. And the author opened a blog in which he publishes projects in which, for his job, he uses visualization. But then at a point, he asked himself, aren't we missing something by just looking at the data? Why don't we also listen to it? And he created these projects in which data are visualized, but also sonified. And once again, Paolo and I found asking ourselves when we were analyzing the cases about this particular example, are visualization and sonification responding to the same goal, or rather one is more in support of analysis, the other perhaps uses music, which is a heavily loaded type of sound, to communicate something else. What is the intention of the author? Intentionality is something that Paolo and I always consider when we relate to the archive, precisely because as designers, the intention that you put in what you create and how you communicate and whom you are creating for is absolutely extremely relevant. So a lot of questions, not many answers, a lot of time taken. I think it's time to give back the stage.
Thank you very much, Sarah and Paolo. Let's give our speakers a hand here.
Sorry, my volume was now very low, so hopefully you heard everything and talk more later.
Okay, I have a question, or we have questions in Slido here. I'm going to start with the first that was posted here at Sarah, actually. What about showing a marker or some indication on the trend line graph that corresponds to the current soundscape? And actually, after the question was posted, you showed such a case, and we were thinking of, in our research group, we were thinking of, is that actually helpful, or might it also distract from the sound? What is your opinion on that, or your intuitive response, maybe?
Sorry, this would be related to the Datascape project, I suppose?
Yes, I think so, yes.
Yeah. Well, I'd like to call Bruce in the conversation. Obviously, I think the real point here is: are we trying to say the same thing with sound that we are saying with the visualization? So again, what is the intention of the two things? To what point sonification has to reproduce what could be more easily perhaps seen in the visualization? In my doctoral research, I mainly focused on real-time anomaly detection in networks. And there, what we really tried to do was a complementary system, because most of the experts that worked there was for cybersecurity of water infrastructure. And most of them told us we don't want to move, we don't want to miss what we do with our current visualization systems, because they work, they're efficient, we really know them, we really can go deep into the analysis. So if you are trying, and actually on the prototype that I created, they told me you are trying to convey too much information. We don't want to know what we already can see on a visual diagram. Sonification is for something else, for accessibility, for example. So we might need to do that, but it really depends on the context and on what we are doing. What do you think, Bruce? I'm reading through the questions.
Sorry, I'm muted. I think maybe we should wait until the panel discussion to get into a deeper discussion of sort of communicative intent.
Yes.
And what we're trying to convey with audio, with visual, and with the multimodal, because we could go all day. So I'd rather us make sure we leave time for the next.
Yeah, wonderful. I think actually there's a question by Michael Krone that we will pick up for exactly that discussion in the end, and it's getting votes here already. So we will talk about this in the end. Let's continue with Victor in that case, and I will briefly switch my screen here so I can introduce Victor to you. Victor Oliveira is a human-computer interaction researcher and lecturer at St. Pölten University of Applied Sciences. He also holds a Master of Science and a PhD in Computer Science from the Federal University of Rio Grande do Sul, where he worked on his thesis on haptic interfaces and their application to computer-mediated tactile communication. Victor works mainly in the field of human-computer interaction, especially in user experience design, quantitative user experience research, data visualization, sonification, and haptization. Victor, thank you for being here. Let's listen to your talk.
Thank you very much for the introduction. I hope everybody can hear me well.
Yes, it's working out good.
Super. So I hope everybody's having a very good conference. As it was introduced, I'm working a lot with data visualization, and I worked as well with data haptization, but I'm here to talk about the project in which I had maybe the first opportunity to work with sonification, but different from the previous applications, it's more focused on not on abstract information, but on conveying sensory data that can be used for motor learning and rehabilitation. So the focus on this project is on gait analysis, and gait impairments can actually be detected and assessed using from the classical apparent diagnosis by medical experts to very sophisticated technical procedures based on motion capturing systems and the gold standard that is force plates that can actually help you to perform a thorough analysis of kinematic and kinetic gait characteristics. And this is important because gait ability can also impact other things like balance and increase risk of falling and risk for lesions, even cartilage loss and so on. So an early diagnosis of those deviations of what we call normal gait pattern or physiological gait pattern, as well as a treatment, is very important for those affected. Yeah. So there are different types of ways that interventions can be performed, mostly in terms of static and dynamic exercises, like standing on one leg or walk in line and so on. And while doing those exercises, the therapists, they are looking mostly into the patient's knee alignment. This figure here on the slide is showing different types of misalignments, and also a representation of the plantar pressure under the person's feet, reflecting those misalignments as well, which would be very easily discriminated also using force plates, because then from the force plates, you can get all the ground reaction forces with all the components that you can use for a full diagnosis of the gait. The idea here is that this gold standard makes that a patient has to go to a specific place to collect this data. And to facilitate that, there are some mobile solutions like sensor instrumented insoles, as shown in the picture right here on the right side. And this example is the Step 1 insole that was created by an Austrian company in which we have a partnership in this research project, that has embedded on it pressure sensors and accelerometers. So it's it easily provides information about the distribution of the pressure under a person's foot, and also the center of pressure. And this tool, this instrument is also provided with a visual analysis tool. So you can see here in this image, that therapists could then use this information visually to assess this distribution of the pressure under the person shoes or in the insoles. Yeah. Still, these sensors by themselves, they do not provide all the different components of those ground reaction forces that are so important. Mostly the vertical one, but not so much the anterior-posterior mediolateral components. So to be able to use such mobile solutions, we need much more information. So there where we come in with our solution. So the idea was in this project, in the Sonigate, to implement a mobile auditory biofeedback system that could be used every day, and not just on a specific place, on a scheduled session, but actually record the normal pattern of gait pattern of a patient, of a client, and also provide real-time feedback. And then here is where auditory feedback becomes so useful, because you could just be walking, focusing on your everyday tasks, and receive simultaneously feedback about misalignments or abnormalities in your gait pattern. Yeah. So to just summarize this process, this long process that we went through, the idea was to show the feasibility of actually estimating ground reaction forces using the sensors from the insoles, but also to be able to run it directly from the insole. Then to show the feasibility of embedded automated gait classification, differentiating what's normal and what's abnormal, and then creating and assessing this auditory feedback that a person can use actually for preventive and supportive applications in physical therapy. Yeah? So just to show the two fronts that we went here, on one side, we were working directly on the insole to make it able to provide those extra informations needed for the understanding and classification of those gait patterns. And it was the first part that we started. So to do that, we actually used the gold standard, the first plates. And here on the right side, I'm showing a picture of our test sessions in which we had 48 healthy participants walking back and forth over those plates and also being tracked by our Vicon motion capturing system. Collecting this information so we could train machine learning models. And we trained different models. We had feed-forward neural network, wavelet, long short-term memory, and we compared the performance of those models to estimate ground reaction forces with the original data collected from the first plates. We got better performances for the feed forward. And on the right side, you can see a chart in which I plot the original ground reaction force from the plates in yellow, and the feed forward results in blue and red, the red one being the one with Butterworth filter. Once we had this model then embedded on the insole, we could continue with discrimination of gait patterns and sonification of it. To be very brief about it, we performed this directly on a separate computer, in which the discrimination between the normal and physiological gait patterns were trained from a data set called gait rec, was data collected prior to our study from also members of our team, including data from over 2,000 patients with impairments. And we use this data for training and testing our model. And then we use this for sonification on real time. The sonification we created on Nex, and we did this interface in which you could see also the values coming directly from the insole for quickly debugging the results, and also the estimations provided by our models. And we also designed some models for training extra patterns in real time. So we would get test subject, we would collect information about how the subject would walk or stand, depending on the different exercises for rehabilitation. We could train it based on the person's pattern and display the auditory feedback. We could also display this auditory feedback for the different legs, so left and right, and with different configurations. We had a wind sound and a trumpet sound, very similar. This wind sound was very similar to the one showing prior in some other example, with also the ability to configure if we would display it when the person was doing something out of the normal gait, or the other way around. So we could compose these sonifications in different ways during the testing sessions. Yep, so overall, we had this sonification or sonified activities being tested by experts, physiotherapists that provide us feedback, but also some usability tests. And at the end, we could show this the feasibility of using auditory feedback to get real-time update on the performance of the person while walking or in static exercises, and also some feedback from physiotherapists which are leading us to follow-up projects as well. And especially now that step 1 insoles are also classified as medical products. So we have also inline some extra studies, but I hope this can give just an idea of a different type of application as well for sonification in terms of presenting also real-time sensory data, which is a bit different from the other applications also presented here today. Yeah, so different from the other examples, I don't have the sounds to play, but here's also some contact from myself and the name of other teammates that worked in the machine learning models, in the as gate experts and also sonification expert are Professor Michael Lieber. And if you are interested in knowing more about this project, you can contact me and we can also discuss more in the question sessions, okay?
Thank you, Victor. I will read one question from Slido to you. And that question is, are the stepstone insoles available for patients struggling with a variety of podiatry issues related to the diabetes? Can you speak on that and how someone can acquire them? Are they actually available already?
Yes, they are commercialized, so anyone can get them. I cannot tell you for sure what's the final price, but they are available on the market. And I wouldn't say necessarily with a specific target patient, for instance, of people, persons with diabetes, but they are accessible.
Are there questions from the on-site audience to Victor? Oh, Bruce posted a link. We will try to publish that in Discord later. If there are no there is an on-site question. One second. I'll bring you the microphone.
Hi. So the field of sonification seems to come around every 20 years or so. And one of the reasons that it sort of faded a bit previously is there was hard to come up with a consensus of how do you represent different attributes of the data. So if you're, for example, trying to represent magnitude, what is the right sonification variable to use? Is it pitch? Is it frequent? Is it repetition frequency? Is it, you know, the volume increasing or decreasing? Is it a, you know, so some things, you know, so I was wondering what progress we're making now to try to find out, you know, what would be, you know, sometimes you want to use sonification to create a mood or an atmosphere, but if you're trying to show an intensity or an intensity over a 2D array, is there some, you know, is it design judgment or is there some consensus?
I think that's a question for the panel, right? And I know that Bruce has quite some experience with this. Maybe you want to start?
Sure. Sonification has been around for 40 years or more. It's not like it's gone away. The researchers have been continuously working in this field, but it is fair to say that there is not a consensus about how to map data onto displays or data onto the auditory components of displays. There have been studies, including my dissertation 1,000 years ago, that looked at that, and those have been published. They're available. I think one of the things that you'll see is that many of the conventions for displaying visual data come from the tool sets. And there's no particular reason why red is hot and blue is cold. So as we build more sonification tool sets and they get more out there, more people use them, the conventions will become de facto standards. And you'll see people using a lot of the same kinds of mappings. We know that pitch works well. We know that loudness is not particularly good as a primary mechanism. It also depends on whether the data you're mapping are continuous, like temperature, or whether they are categorical, like city by city by city. So all of the same kinds of data considerations that are part of your mapping choices in a visualization go into the decisions in a sonification as well. But I think the bottom line is, as the toolkits and become more and more prevalent, you'll see more and more standardizations.
There's one more question from the audience. I'll give the microphone.
I just wanted to follow up with that. So in vision, at least, there's a large growing psychology of mapping visual features onto concepts. And people do have really clear expectations of how visual features should map to concepts. So we've been creating a framework that actually unites both categorical and continuous data under a single framework. My student Melissa Shainline presented that yesterday. Sorry, I'm Karen Schloss. So I think a lot of the theoretical work we've been doing in vision has great potential to extend to sonification. And I think there's really cool opportunities for collaboration there of taking existing frameworks and really using it as a way to launch a principled way of mapping sounds and textures and other types of perceptual features to data. So I think this is a really, really exciting area to work in. And I think those kinds of collaborations between people who are working on making the tools and people who are doing the science understanding the mapping, I think should talk more.
Thank you so much. Did you guys hear everything? Yes. I think
Yes.
Sarah actually would be a person quite entitled to talk about this.
Thank you, Kajetan. I wanted, in fact, to follow up to Bruce, of course, whose work I know, and I went quite a few times over it during my PhD thesis writing. So yes, there's no consensus. I think a lot, and I think Paolo would agree, based on the work that we've been doing in these last years. Consensus, or I mean, standardization of the field goes also obviously through creating tools, sharing these tools, and making designers or people that work with data representation on different levels experiment with sonification, because until it remains a very small domain in which people that want to do sonification typically also produce their own tools, but then the scalability of the tools may or may not work. Then of course it's more difficult to reach a consensus and a standardization. And then we have all the topic of education and literacy and relating to sounds. I mean, not only using sound to represent data is not standardized in the mapping strategies, but even analyzing sound and soundscape is not standardized. You can take it from so many different angles. Psychoacoustics is one thing. The physics of sound is another thing. In fact, we talk dBs and then loudness, depending on the perspective you take. Is the listener, or is the sound as a physical phenomenon? And then again, you have sound sources identification that is more, related to the context of experience. You have different levels of attention. You have many things that, in general, sound studies, I think we can say they are a little bit behind what happened with visualization. In terms of what we are doing with the archive, going back to this last comment, is selecting subsets and analyzing these subsets, conducting reviews and systematic reviews or semi-systematic review to identify whether there are common strategies in the visualization and the sonification of sound, and if these strategies can be compared. And also whether we can get to the point that we have a common language. Otherwise, that would make it difficult to optimize the design of this unique product that uses both sonification and visualization. The sonification canvas goes in that direction that Paolo showed, to start introducing the use of sound potentially to data visualization designers, and see how this can be integrated in existing processes, and see if we can get to a common language in that. Paolo, you want to also comment?
I just wanted to add that consensus is a process, and I think needs a kind of a critical mass. It happened in data visualization in the early 20th century. So we had this certain controversy around certain modalities, and so it happened. But we had a kind of a critical mass of scientists and scholars working on the field that could create that sort of consensus. And I think that Data Sonification Archive is part of that process of creating enough critical mass that enable that kind of reflection that will eventually, hopefully, lead to a sort of consensus. But it's a process. It's typical of the scientific community. So to reach to a certain sort of temporary consensus around something by doing science and research, by elaborating, and I would say that just simply maybe we don't have that yet. We don't have that critical mass that allows for a kind of consensus to be created and then to become, a cultural convention or a convention broadly outside publicly. So it's a process, and we are trying to foster that process through this little object that we created.
Thank you so much. We have 3 more questions here and only a few minutes left. So we'll give the microphone to you first, and then I'm gonna ask you for quick answers this time again, and quick questions.
Hello, this is Yana from Hong Kong UST, and I have general questions about the sonifications for visualizations. In visualizations, there are many visual channels like position, color, and so on, and they are independent and separated. But for audio channels, we have pitch, pan, and volume, and so on, right? But they are interact with each other. So I want to know whether the is it possible that we can map the visualization to sonification accurately, especially for those visualization with many attributes? Yeah, thank you.
Who wants to chime in for that question? Just go for it.
I'd say it really depends on what you want to do. Perhaps I'm being too much of a designer in this sense here, but again, in my experience, you might want to find an accurate correspondence between the rules of visualization and the rules of the sonification, but it really depends what you want to do and if needed. In my experience with real-time monitoring and anomaly detection, for example, it wasn't needed. Even when we tried, actually, the listeners said, we don't want something to replace sonification. We want to leverage the characteristic of sound of being one event that contains multiple variables at a time. We don't want to lose that richness, but we want to use it in a different way. So in my case, it was to give a synthetic idea of how the system works. And then you would go to the visualization to have more analytical information. It really depends what you want to do. Bruce?
Well, I would also push back on the idea that the dimensions in visual displays are separable. We know that size and color combine. We've known this since Piaget. But there are conventions that are used in the visual display. Some auditory dimensions do interact, but some are separable. Pitch and stereo location are completely separable. So we know how these, as sonification experts, we know how these can be used, and they can be used in combination with visual displays to make an accurate and sort of a comparable auditory representation of your data that is, tells the same story as your visual representation, if that's what you're looking for. It's not always what you're looking for.
Thank you very much. It's 12 o'clock now, so basically lunchtime. Whoever wants to go to lunch already is very free to do so. I will be so free and take one more question for those who want to stick around for a few more minutes. and hand over the microphone.
Thanks. Hi, I'm Shilpi from NOAA Science on a Sphere. I was wondering if we can learn anything from sound design in gaming for scientific visualizations. I imagine that's been studied quite a bit.
There was actually a question on Slido that was asking whether it was ever, but then my Slido disappeared. But anyway, it was asking whether it has ever been tried, same visualization and different sonifications with different emotional connotations, and to see how they would impact the understanding of the visualization. I'm not aware of any study that did that, but this is what you would do in cinema, right? Sound design for film does a lot of these things, and I feel that sound design for gaming is close to this approach, influencing the narrative through choices of sound design. I totally think that some of these principles can be borrowed by sonification and driven towards different goals. So I'm in favor of that, and I also try to make it real in my sonification work. Personally, I'm in favor of that. Yeah.
Yeah, absolutely. To second that, and we do that, right? So sound designers or Foley artists or composers are all using sound to tell a story. And when you're doing some kind of sonification or data visualization, you're also telling the story of your data. So we absolutely borrow and leverage things that are done in film and in games. But remember that those are just conventions that come about based on one person came up with the idea. We all know exactly what the correct sound of a lightsaber is, right? There can only be one lightsaber sound now because it's done, and we all know that's exactly the sound. But that's a convention that came about. So we can leverage those things, but we have to be sort of aware of what is a de facto standard and what is something based on psychophysics or perceptual studies.
Thank you so much for your answers to the questions. Michael Krone's question is actually answered by now. So I want to thank you, all of you, one more time, and also thanks to coming to this session. And I'm gonna ask our technicians to switch back to my slides for 1 second. With this QR code, you can get in touch with me. You will be able to send me an email. If you want to be part of the AVAC mailing list or want to get in touch on any other topic, please do so. Have a great lunch. Have a great rest of the conference. Approach me if you're interested in all of this, and see you around. Thank you, everybody.